Hello my dear COMEDK aspirants, so welcome to Diksha Karnataka YouTube channel. And for so many days you are asking, sir please help us, sir please help us. So I decided, okay, why not help you out quickly without wasting your time. That is, I am going to share the formula sheet that will be very helpful for your upcoming COMEDK exam. So first of all, I will share the formula sheet. I will show you how to use it as well, but you have to download the formula sheet PDF. Obviously 28 chapters are there. I cannot explain all the 28 chapters in this short video. So basically I will share the PDF with you. You should download the PDF from our WhatsApp channel. The link of the WhatsApp channel is given in the description. Those who are new to our channel, those who have already joined our WhatsApp channel, they will get the drive link. From there they can download the PDF of this file without any wasting time. Let us move on to the formula sheet. So it is basically chapter wise. First few chapters are obviously first 14 chapters are from your class 12th or PU2, and then we have PU1 or class 11 chapters. Okay, so let us see what are all there in the formula sheet and how you can use it better. So this formula sheet is basically a tool for you to revise all the chapters quickly. Okay, so if you see that here we have Coulomb's law. Now normally Coulomb's law is very simple. F is equal to Q1 Q2 by R square. K is known, epsilon naught is generally given in the question. Then what should we why should we remember it? Because in some cases they will not give you directly about Coulomb force. They will say that, okay, if certain distance of the medium between the charges, so there is a charge Q1, there is a charge Q2, and you have added some length of a dielectric constant K, then what will be the Coulomb force between them? For that you have to remember that this is the formula. So if the distance is x, this distance is r minus x, okay, so the total distance, effective distance, will be root k into x, root k into x plus r minus x. So this will be the effective distance, and this distance you have to substitute in this equation to get the force. Now if the entire element is filled with dielectric constant, then simply putting root r root k in place of r should give you the answer. So this is how you can remember what are all the formulas, what are all the important concepts that I have to remember. Similarly, if you keep a charge in free space, the electric field produced by this charge is given by kq by r square, and force experienced by another charge kept in a electric field is given by force equals to Q into E. So these are the all basic formulas. Next we have dipoles. So all the formulas of dipole, remember all the formulas that you learn for electric dipole is equally applicable for magnetic dipole. In COMEDK, magnetic dipole is very common type of questions that is being asked all the time. So dipole moment is P equals to Q into 2A. Direction is from negative to positive charge. Electric field, for points on the axis, electric field is given by 1 by 4 pi epsilon naught 2p by r cube. For points on the equatorial plane, it is minus 1 by 4 pi epsilon naught p by r cube. So basically axial electric field is in the same direction of dipole moment. Equatorial plane electric field is opposite to that of the dipole moment. So that's why there is a negative sign. Now in case of torque acting on the dipole moment, so obviously the relationship between them is this is twice, sign is negative, etc, etc. Torque acting on a dipole is given by tau is equal to P cross E or PE sine theta magnitude wise. So if the theta value is 90 degree, the torque becomes maximum. If theta value is 0, torque becomes 0. Okay, in case of magnetic field, you just need to change P with M and E with B. Okay, so in case of magnetic field, the same torque will be MB sine theta. Okay, MB sine theta. Okay, now potential energy of the dipole is minus PE cos theta. Potential energy can be tricky, so remember that if the theta value is smaller the theta value, smaller is potential energy. So potential energy is minimum for theta equals to 0, and potential energy is maximum for theta equals to 180 degrees. Okay, cos 90 is not minimum potential energy. For potential energy, this is very, very specific point. So cos 90, even though it is 0, 0 is not minimum because potential energy is negative. Okay, so that is one very important point to remember. Potential due to a dipole 1 by 4 pi epsilon naught p cos theta by r square. So only one point you need to remember, potential energy is inversely proportional to square of the distance. So that is a very specific point to remember. Now let's move on to the Gauss's law and application. So Gauss's law tells that electric field basically given by E dot ds is q by epsilon naught. Now E dot ds is actually the electric flux which is enclosed by a surface, and for infinitely straight long wire, the electric field is given by 1 by 4 pi epsilon naught 2 lambda by r. Field due to an uniformly charged infinite plane sheet, it is given by sigma by 2 epsilon naught. Based on this, some questions come. Now remember that if the plate is large, and the distance is small, you can still apply this formula. Okay, if the surface or charged surface is large compared to the distance between a charge and the plate, then still this formula is applicable. Field due to an uniformly charged thin spherical shell or conducting sphere, same formula, E is equal to 1 by 4 pi epsilon naught q by r square for points outside the shell, and inside the shell electric field is 0. If you plot the graph, it will be looking like this. Okay. Now let's move on to the next chapter, electrostatic potential. So as you can see, very quickly you can revise the entire concepts. That is why formula sheets, having a formula sheet is very, very important. Now electric potential is given by, so this is basically potential energy. The first one is potential energy. Okay. So difference in potential energy is basically work done. So when you are moving a charge inside an electric field, you are doing some work. So that work is basically stored as the potential energy of the system. From the potential energy, we can define potential. Potential is basically work done per unit charge. Okay, potential is basically work done per unit charge, and potential difference is basically if you calculate the potential difference, that is more important. Now if you take the starting point as infinity, so if you bring a charge from infinity to a point, that gives you the value of potential at that particular point. Now potential energy of two charges is given by 1 by 4 pi epsilon naught q1 q2 by r. 3 charges, you have to take pairs of individual charges and their corresponding distances. Okay. Now electric field is also can be written in terms of potential, which is minus dV by dx. Now if you compare the potential and potential electric field due to a point charge, the graph comparison graph looks like this, right? Now next is capacitance. Again, capacitance is also super important in COMEDK. So capacitance, normal capacitance is Ka epsilon naught by d. Okay, K is dielectric medium between the capacitor plates. Okay, capacitor based questions are common, combination of capacitor based questions are common, and also you need to check that if part of the capacitor is filled with a dielectric medium, some similar easy type of JEE level questions do come in COMEDK exam as well. Series combination of capacitors is basically one reciprocal addition, and parallel combination is basically addition in normal addition. Okay, when two capacitors are in series, you can apply this shortcut formula to calculate the capacitances. Okay, now if all the capacitors have same value, in many cases they have, so in that case you can directly calculate the series equivalent, which is given by C by N, and parallel equivalent, it is N into C. Okay, now energy stored is given by half CV square or half QB or half Q square by C. Energy density is given by half epsilon naught E square. Okay, now let's move on to the next chapter, current electricity. Current electricity is again another important chapter. Those who are coming from KCET, they know that current electricity is important chapter for KCET, but it is also important for COMEDK exam as well. So current is equal to Q by T, I is equal to limit delta T tends to 0, delta Q by delta T, and that is dQ by dt. So Ohm's law is equal to V equals to IR, J is equal to sigma E, E is equal to rho J. Okay, drift velocity is given by minus E epsilon naught. These formulas are not super important, but you need to remember current is given by NEA VD. Okay, and also the equation of continuity, which says that area into drift velocity is constant. Okay, area into drift velocity is constant, that is for current as well as for fluid also. So either fluid or current, there is a chance that this concept based questions might come. Current density formula is here, mobility formula is also given. Conductivity is basically 1 upon resistivity. Sometimes students get confused between conductivity and resistivity, so that's why it is also there. Now both resistance and resistivity do change with temperature. Okay, so resistance, either you can write the same formula in terms of resistance as well. So RT equals to R naught 1 plus alpha delta T. Okay, alpha is called coefficient, temperature coefficient of resistance, okay, or resistivity. Both same quantity. Resistance and resistivity are same, at least for this equation, because you know that resistance is rho L by A. Now if you put this value in this, both side L and A are constant, so they will cancel. So you can write in terms of resistivity, you can write the same terms in terms of resistance as well. Now coefficient of resistivity normally is given by rho T minus rho naught by rho naught into T minus T naught. But in terms of resistance, it is RT minus R naught by R naught T minus T naught. Okay, and if this is only valid when the temperature, generally T0, if T0 is equals to 0 degrees Celsius. So you can use this formula. But if the temperature 0 is not given, then you have to use this formula. If the temperature is given, say resistance at 40 degrees Celsius, resistance as 50 degrees Celsius, what is the alpha, or alpha value is given, resistance at 40 degrees given, they are asking you what is the resistance as at say 50 degrees Celsius. In that case, you have to use this formula. Remember, higher resistance minus lower resistance divided by lower resistance higher temperature. So basically the order inverses. For resistances, the order inverses. So if you remember the top portion, bottom portion you can automatically remember. So order reverses, but temperature is of the same order. So initially we did RT2 minus RT1 divided by RT1 into temperature T2 minus RT2 into temperature T1. Okay, so this is a way to remember, memorize difficult formulas. Okay, now let's move on to the next part, combination of resistances. Combination of resistance is almost obviously opposite that of capacitor. So if you remember capacitor, you can remember resistance as well. Obviously resistance is you are more familiar with, you are using it from since class 10th. So series is addition, parallel is reciprocal, exactly opposite that of capacitors. For two resistors, R1 R2 by R1 plus R2. Now and same for n number of equal resistances, same formula goes. So NR, it is R by N. Now remember here this is reciprocal. Okay, that is one important point to remember. Next, energy is equals to H is equal to VIT, power equals to H by T, VI I square R, and that is equals to V square R. Now cells in series and cells in parallel, generally complicated questions, too much complicated questions do not come in COMEDK, but still cells in series and cells in parallel based questions might come, so you have to be prepared. So epsilon equivalent is sum of all the epsilon by resistances divided by 1 upon all the resistances, okay, and equivalent resistance is reciprocally added. Okay, current in the circuit is equivalent EMF divided by total resistance. Total resistance is external resistance plus R equivalent. Okay, now moving charges and magnetism, this is the last chapter that I will discuss in detail. Then from there on I will just show you the chapters. So Lorentz force F is equal to Q into E plus V cross B. Radius of circular path is mv by qb. Angular frequency omega is equal to qb by m. Time taken to complete one revolution is 2 pi by omega. Next, Biot-Savart law, even though Biot-Savart law based questions never came in COMEDK, but who knows what will going to come in the next exam, because it's an easy concept. So Biot-Savart law gives you the magnetic field due to a small current element, which is given by dBp is equal to mu naught by 4 pi I dl sin theta by r square, and mu naught by 4 pi value we know it is 10 to the power of 7 into 10 to the in Tesla meter per ampere. mu naught is called permeability of free space. Force acting, now this is important, force acting on a current carrying conductor, the exact formula is not visible, but F is equal to IL cross B. Okay, so if 2 points are given, okay, 2 points are given, suppose the current is being flowing like this, current is flowing like this. So basically this is your L vector. L vector is starting point to ending point. This is your L vector, and from there you can apply this formula. So this type of question did came in COMEDK in the past, so make sure you are using the vector formula, which is IL cross B. Okay, so this is how you should find the force on a current carrying wire. Current carrying straight conductor, magnetic field is mu naught by I 4 pi r sin theta 1 plus sin theta 2 when theta is measured from the point. If you are measuring these angles, it will be cos theta 1 plus cos theta 2. Okay, so either you are writing like with respect to this angle or that angle, this becomes cos. Remember, with respect to these angle, this is cos, and with respect to this angle, this is sin. Okay, so I have used sin theta formula, you can use cos theta formula, but in that case these angles you have to use. So this is say phi 1, this is say phi 2, this will be cos phi 1 plus cos phi 2. Okay, for long wire it becomes mu naught by 2 pi I divided by r. Okay, circular loop carrying current, B is equal to mu naught I r square divided by 2x square r square to the power of 3 by 2. Case 1, at the center of the loop, B is equal to mu naught I by 2r, and for x very greater than r, you can write this in terms of the magnetic moment of the circular loop. Now magnetic moment of a circular loop is basically given by NIA. Okay, magnetic moment of a circular loop is NIA, number of turns into current into the area. Okay, so that is National Investigative Agency. Now force between two parallel currents is basically given by unit length, mu naught N IA IB by D. Okay, this is the force per unit length, and if you want to calculate for force given of certain length, you have to multiply it with the length. Torque on a rectangular loop, tau is equal to NIAB, tau is equal to NIA plus B. Okay, NIA, as I mentioned, is basically the magnetic moment. So from there you can calculate torque is equal to M cross B, and potential energy is same as MB cos theta. Okay, so torque is MB sin theta, potential energy is MB cos minus MB cos theta. Okay. Now magnetism and matter is there, so I will just show you the entire PDF slowly. Okay, moving charge, magnetism and matter, electromagnetic induction, all the formulas are given, alternating current. So basically you can revise all the chapters. I think there is a small error in these formulas, slight error. This will be square outside, and in terms of current it will be again outside. Okay, so all the basic formulas are given here. You can revise it quickly. EM waves, equation of wave, okay, and their corresponding relations. We have ray optics, again all the formulas are listed here. You can quickly revise what are the different relations. Okay, spherical mirror, spherical interface, lens equations, optical instruments, okay, wave optics, all basic formulas are given here. Okay, next we have diffraction, polarization, dual nature, atoms. Okay, all the formulas you can check here. Nucleus, nuclear binding energy, semiconductor, basic formulas of semiconductor, units and measurement. So basic quick revision of all the concepts you can do it from this single formula sheet. Okay, laws of motion is there. I think there are some formatting error. I will try to fix that. Then we have this. Okay, all the formulas, important formulas are listed in this formula sheet. So don't forget to download. The download link is given in the description section of the not this description section, but it is there in the WhatsApp channel. So don't forget to join our WhatsApp channel and definitely download the formula sheet. This is going to be very helpful for all of you. Now I just wanted to tell you about one of these concepts: one-sided open pipe, both-sided open pipe. So for one-sided open pipe looks like this, both-side open pipe means looks like this. Okay. Now fundamental frequency in one-sided open pipe looks like this. In both-side open pipe it looks like this. Okay. Now when we say overtone means the order higher than the fundamental frequency. So if I say second overtone, that means the number is actually 2 plus 1. Second overtone, the order of the frequency is n, which is order, which is called harmonics. Harmonic wise, overtone and harmonics are overtone is basically, if I say second overtone, that means third harmonics. Okay, and if you see that in case of one-sided open pipe, only odd harmonics are present. In case of both-sided open pipe, all sorts of harmonics are present. In some cases, if you are confused, draw the diagram to solve the questions as well. Okay, so this is the formula sheet as I mentioned. Please don't forget to download it from the WhatsApp channel, and that will be very beneficial. And if you like this video, don't forget to give it a thumbs up. I'll be trying to do more lectures on COMEDK series very soon. Till then, bye.